All right, for a couple of you, I had somebody ask me a question and I realized I owed you an explanation. And this goes back to the spring when we went into lockdown, and some people might have missed this part about acids and bases. So for your homework on 1978, because it's asking you to compare what happens to the freezing point and electrical conductivity. So here's sucrose. This is what sucrose is. C12H22O11. And you don't really need to know the formula, but it's helpful. Well, when it goes into solution, you just get the aqueous particle. Okay? Sodium formate. We haven't seen formate before. You know what sodium is? Metal. Well, that's a polyatomic ion. So when it goes into water, you get 100% splitting of sodium, and then formate, which is a polyatomic anion, which is negative. Just think of it like as a big chloride. That's all, okay? Then you get formic acid. And when you get acids, it's H plus. Well, now you know what formate is. But here's the kicker. If you were with me in the spring and we're doing acids and bases, there are strong acids and weak acids. If you're a strong acid, you split up 100% like something that's ionic. You break up as like 99.999%. It's ridiculous, okay? But there's only 6 strong acids. Hydrochloric HCl, hydrobromic HBr, hydroiodic HI, nitric HNO3, sulfuric H2SO4, and then perchloric HClO4. Those are the only 6 that break up 100%. The rest of them are weak acids. And that means when you put a weak acid in water, you don't get 100% splitting up. It means if I've got 1,000 of these particles, for instance, to start with, when I end, I've got like 997. Oh, well, that means 3 of them split. I get 3 and 3. It's something that doesn't break up all the way. It's like an ionic substance that you throw into water and barely any of it dissolves. Same idea. So a weak acid means I've got a lot of this sitting around, and when it goes into water, well, when it finally dissolves, I still have a lot of this sitting around, and I get a little bit of this and a little bit of this. And in order to solve 1978, you've got to know that. So because of what happened when we went into lockdown, I saw the problem as like, oh, this is going to be great to solve because it brings back into the difference between covalent and ionic with the electrical conduction, and then what happens when things split. But then I didn't realize some of you might have missed the weak acid portion. So that's your explanation. I want you to think about this like, oh, if I've started off with 1 million of these, when I get done, I have like 999, 9 million, or dadgummit, can't write today. 999,000 900, 100, and 100. It doesn't break up that much, okay? And that's what it means to be a weak acid. Okay? There's your explanation. Now you can go after 1978.